Probably, each of us at least once in our life. When looking at the sky, thought deeply about whether the universe has an end or not. Does the universe have a limit? How big is it? The universe is a concept that we think is infinite, like mathematical numbers. There have been various opinions about the size of the universe in the past. The first exact numbers were revealed in 1838 by the German physicist and astronomer Friedrich Bessel. Bessel tried to approximate the distance of some nearby stars, and as a result, he calculated that the star 61 Cygni is about 10 light-years away from us, or 93 trillion kilometers. Until the beginning of the 20th century, it was generally believed that the universe consisted of our Milky Way galaxy, but then in 1923, Edwin Hubble calculated that the star system named Andromeda was too large to fit in our galaxy and realized that Andromeda is a separate galaxy, about 2.537 million light-years away from us. And after that, it was understood that the universe is much, much bigger than we thought. According to the latest calculations, the universe is 93 billion light-years wide. But how is it that the universe born 13 billion years ago is 93 billion light-years wide? This is related to the expansion rate of the universe, as we know. The universe continues to expand constantly, and the speed of light is not a limit in the expansion of the universe. Can you imagine how big 46 billion light-years is? Today we will try to understand together how big this distance is. First of all, let's start with ourselves. The Earth is our home on which we stand, which appears as a blue dot in the solar system. In fact, the Earth is not a small place. For example, if we get into a car moving at a speed of 100 kilometers per hour and circle the world without stopping, it will take us about 17 days. Let's assume that we circle the world by a plane, moving at a speed of 800 kilometers per hour. In this case, it will take more than 2 days to go around the world for a full cycle, which means that the Earth is really not a very small place. Now let's move to the Moon. The Moon is the most recognizable object in the night sky, and the average distance between Moon and Earth is 384,400 kilometers. Let's assume again that if we set off towards the Moon, with a car moving at a speed of 100 kilometers per hour without stopping, it will take us more than 6 months to reach the Moon. Although the distance seems very long, we landed on the Moon in 1969 with Apollo 11, and a total of 12 people managed to go to this celestial body. Anyway, let's continue our journey. There are still many planets, stars, and other celestial bodies waiting for us. The Sun is the star at the center of the solar system. It is a massive, hot ball of plasma, inflated and heated by nuclear fusion reactions at its core. Part of this internal energy is emitted from its surface as light, ultraviolet and infrared radiation, providing most of the energy for life on Earth. The Sun lies at the heart of the solar system, where it is by far the largest object. It holds 99.8% of the solar system's mass and is roughly 109 times the diameter of the Earth. About 1.3 million Earths could fit inside the Sun. Although the Sun seems very close to us, the distance between us is 150 million kilometers. Again, if we move towards the Sun with our car, It will take us exactly 177 years to get there. Can you imagine how big it is? We haven't even left our own star system yet. Now let's move on to more distant celestial bodies. Proxima Centauri, the nearest star to us, and it was discovered by Scottish astronomer Robert Innes in 1915. Located about 4.2 light-years away. This red dwarf star has 12.5% of the total mass of our Sun. Proxima Centauri lies in the constellation of Centaurus, although it looks bright through the eye of Hubble. As you might expect from the nearest star to the solar system, Proxima Centauri is not visible to the naked eye. Its average luminosity is very low, and it is quite small compared to other stars. And if we were to travel there again in an airplane traveling at 800 kilometers per hour, it would take us about 5 million years. Sirius is the brightest star in the night sky. Sirius appears bright because of its intrinsic luminosity and its proximity to the solar system. At a distance of 86 light-years, the Sirius system is one of Earth's nearest neighbors. Sirius is gradually moving closer to the solar system. It is expected to increase in brightness slightly over the next 60,000 years, to reach a peak magnitude of 1.68. Betelgeuse is a red supergiant star of spectral type, and one of the largest visible to the naked eye. It is usually the 10th brightest star in the night sky. Betelgeuse is approximately 650 light-years away. Betelgeuse is also one of the largest stars. It's about 700 times the size of the Sun and around 15 times more massive. In fact, Betelgeuse is so giant that, if we replaced our Sun with Betelgeuse, it would stretch past Jupiter's orbit. Betelgeuse has evolved rapidly because of its large mass, and is expected to end its evolution with a supernova explosion, most likely within 100,000 years. When Betelgeuse explodes, it will shine as bright as the half-moon for more than 3 months. This is the Milky Way galaxy where we are located. It's much bigger than you think. So big that you can travel 100,000 years from one end to the other at the speed of light. And it contains over 400 billion stars, about the size of our Sun. For comparison, if we take it as a small penny. The Milky Way galaxy is the size of the American continent, but our galaxy is also considered a small point in the universe, because it is thought that there are more than 2 trillion galaxies like our galaxy. Although there are so many galaxies, the closest neighboring galaxy to us is 2.5 million light-years away. The Andromeda Galaxy is a barred spiral galaxy, and is the nearest major galaxy to the Milky Way. It was originally named the Andromeda Nebula and is catalogued as Messier 31, M31, and NGC 224. Andromeda has a diameter of about 152,000 light-years. If we look closely, we can also see brighter galaxies. These are quasars that were formed in the early days of the universe, and then we see traces of the explosion of the Big Bang. Given that the universe is expanding at a speed greater than the speed of light, these numbers may be 200 times or more. But these are still only a possibility in any case. We already understand that we are a particle as small as an atom in the universe,